Hello everybody! Today we're going to go over data extraction. We're going to extract information from a website and upload it to a system like PrestaShop. So, we're going to start with this example website that we'll pretend is on an e-commerce webpage. The link is in the description. First of all, we're going to go into our web interface. Here, create a new script file. I will call it test data extraction. And I'm going to click this button here because we're going to be writing a crawler script. And we're going to need 3 different scripts. We're going to have to write in the 4-page section because we're going to have some actions to do on every page. So, we're pretending that Ideatech here is an e-commerce. So, up at the home page of the website here, this will be the page of depth 0, where the crawler will first go. It will then take all the links on the home page, that is to say, all the text in the ref A tags, and those pages will be of depth 1. The crawler will then visit each of those pages, run the 4-page script, find all of the unvisited links on those pages, visit those pages, and so on, until either we reach the max depth, specified here, we've visited the maximum amount of URLs allowed to visit, or there are no more new links to crawl through. And this last one is usually how it stops. Now, although I've put my home page here to crawl through the whole website, I'm going to start by testing on a specific page, the shoes test one. I'm going to go to this tab and paste in the test page. On an e-commerce website, I'll take the page of a random product. And since the product pages are the same layout, once you've successfully extracted data on one, you can get them all. Usually. Sometimes there are multiple layouts, and in that case, you will need multiple test cases, but that's rare. A web page, by the way, is actually this, the source code. The source code will come to be compiled as the DOM, Document Object Model. Now, the DOM looks like the source code, but the DOM actually has some differences. For example, notice how in the source code, there's a lot of space between here and the slash. In the DOM, this doesn't appear. Although we will usually use the DOM for ease, know that the crawler goes through the source code, not the DOM. Now, you can see that the title is here. So, how do we get the title? Well, the first way I do not recommend is to simply copy the CSS selector. We see here the CSS selector is .title, but we should check to make sure. Now, here we can see that there's a first problem, because the search here is going to also do a text search on top of the CSS selector. Not ideal. So, this is not a title element, and certainly not the one that we want. And then here, we can see that this is indeed what we wanted. Here's where we can test the robustness of this search. Ideally, we would want our search to turn up only one result, to remove all ambiguity. The less ambiguity there is, the more robust the code. And we want our code to be robust, especially in web mining. That said, we need to strike an ideal balance in our specificity. It's no good being too specific in our search, because web pages are dynamic and ever-changing. For example, if I search for this specific term, then I will get what I want, but if the web developer decides to change the name of this class to card, for example, then the search doesn't work anymore. We will never be perfect, and definitely there will be times when our searching breaks, but we will want to minimize that as much as possible. One of the ways we can do that is to search for information by their quality. For example, if there's a class called bold title, well, we most likely want to search for title and not bold, because most likely the web developer will have reused that keyword for other words that are in bold. This will help us in determining on whether some keywords are more specific than others. Now that we have our CSS selector, we can go back to Grimport and start with a variable. I can select and put my CSS selector in here, and here I can leave blank, but I can also put code to signify the page's source code. This code variable has been defined elsewhere and is different on every page. It doesn't exist in the initial or final scripts because we're not crawling on those scripts. In the initial, it's setting up the crawler, and in final, it's ending. So they're not related to what the crawler is doing on a page. Again, I'm just going to leave this blank because these are optional variables. You will also notice that on the Test tab, we can test the CSS selectors. I can put my CSS selector here and test that it does indeed work. Now, if I want the images on this web page, I'll write img, and I'll want to use the select all function because I want all of the images on the web page. We're going to want to select something different here because we need to retrieve a different part of the HTML. Now, for starters, there are 3 different options here. Let me demonstrate the difference between each of them. So, if I have this, for example, and I search for .title, then this would be the outer HTML because it includes a tag where we found .title. This is the inner HTML. It's all the HTML that are enclosed by the tag containing .title. And this is the text, the part of the code that shows up on the web page. I can also search for specific attributes within the tag. For example, if I want the image source, then I have to specifically look for, it's src here, so that's what I'll input into the selector. And as we can see, we do indeed get the different image sources. Be careful, because by default, this is set to inner HTML. As we can see on the web page, there's nothing in the inner HTML. So if we test this, we get nothing in the function. Moving on, we now want to get the reference. But there's a problem. If we go back here and paste in part number, then we get this. Well, we only want this, but we get this. Well, it's not the end of the world. I can paste this here, and since we don't know how to remove this first part, I can go to the documentation and look up what I want. So, it could be CSS, or delete, or remove, or I could be really precise and search up remove element. Now, there are no results, but that's because it's not searching through the descriptions. If I click here, it now does, and I can see that I get more results. Remove element seems to be the most promising, and well, if I read this, it seems that I can remove a tag given its name. So it does seem well suited to my needs. I can also search by a category if I want. Probably text is the category I want in this case. And if I look up remove, I see that I get the function I want. Also note that I can highlight the function and click the button to see the documentation for this function. I can add the function here, and I want to remove strong, no dot needed, and now it's good. We can check by setting a breakpoint and running a debug by clicking this debug button here. Not this one. That one will do all the pages. This one does just this page. Let's see. Yep. It's good. Now, web mining is a subcategory of data mining, and as a general principle, we should never trust data. This is because it could be badly or not encoded. For example, the ampersand actually looks like this in the DOM. There are also really similar characters. Like, did you know there are 2 different types of quotation marks? Yeah. If you try to search for the presence of one type, and it's actually the other type, you'll get nothing, and you'll be very confused. So we have to clean up the text to make it ready for using. We can use standardized text for this, and as you can see, if there are things like ampersand e acute, it replaces it with the corresponding character, and so on. And we can also use strip tags to remove the HTML tags, and trim to remove the extra spaces on the edges of the string. I can use HTML to price to get a price value, and number to transform a string to a number. And we can also have negative values. Now this is quite long, so we can shorten it to clean select and do these 3 actions in one. Now I can do something interesting here in the post-processing. In the post-processing, I can modify it based on my needs. For example, by default, it does strip tags and standardized text. But if, for example, I want to keep the formatting, the bold and the italics and the underlines, well, I can write D or description and do only standardized text, leaving the tags untouched. I can also do price or integer, and I can also do these ones. This one in particular I want to spend some time talking about, because sometimes when we're comparing between suppliers, PrestaShop has characters it won't allow. So when doing the comparisons, it can be useful to remove the disallowed characters. Now, let's say we want to retrieve this comment here. This is more complex to retrieve, so we'll use regex for this more complicated data. Now, I can use the regex function, but I'll use the clean regex function, which does the same thing as clean select, but for regex. Let's write a regex. To start and end an expression, we use the slashes. In the beginning, we'll write $SI. This S means that we can search over multiple lines, and the I means that we don't care about the case, upper or lower case. Okay, so now I want to find this, so I'll copy and paste this. As you can see, there are some line breaks in between the start of the comment and the next line. On other pages, there could be different amounts of line breaks, so I'll say that there are a certain amount of line breaks in between. \S designates the white space, think space, tab, line break. Star here means 0, 1, more. Compare that to plus, which means 1 or more, and question mark, which means 0 or 1. Same here, and another here. We have dribble, and then this is what we want to retrieve. I'll put brackets here, and this indicates that I want to only have letters from A to Z. It can be any of them, but it can't be something else, like a number. If I want to exclude a letter, like the letter B, then I have to use the circumflex symbol. So here, I want to exclude the line break at the end. I want to exclude things that indicate the start or end of a tag, because these definitely don't belong in the URL. And of course, this URL is surrounded by white space, so I'll add some \s here. Now, we can keep excluding, and certainly there are good arguments for doing that, but this is all subjective. So I'm just going to stop here for simplicity's sake. Now that I have my regex, there are two different ways of testing this. First is this website, and then I'll paste the regex here. Oops, I forgot the plus here, so that I can grab the whole URL. Paste the source code here. As we can see, it worked. We can also use Notepad, paste the source code here, hold Ctrl F to bring up the search, click regular expression, and tick this, and paste in the code and expression. We'll find the same result. Okay, great. We have the search term. Now how do we extract the information that we want? Well, we can use masks. Masks are denoted by parentheses. Here, the information we want is the URL, so we'll surround it with parentheses. Note that parentheses can also be used to do OR statements. So this means either search for that or John Doe. Now, this we can ignore, but the mask number, yes, we will have to specify that we want mask number 1. Sometimes we'll have multiple masks, and we'll want to know the mask number of a mask. To find it, what we do is we count the number of open parentheses from the beginning. Except this one. This isn't a mask. So here it's 1, 2, 3. So mask number 3. You can find more information on the documentation page. To make sure we have the correct mask, we can go here, select regex, paste the regex, and type in 3, and we see that we do indeed have the correct mask. We can also start the debug, find that I accidentally forgot to fill in the post-processing option, then select the function, do Shift-Control-I, and get the same answer. Thank you for listening. This concludes part 5 of this series.